Okay, so now we want to find the absolute max and min of the function on the given interval. So here we have x squared plus 4x on minus 3 to 3 for part A. So A, what do? We look for critical points first, and then we plug in any critical point on the interval and the endpoints. And this is basically using the extreme value theorem together with another theorem. So A, x squared plus 4x, if I call that f of x, then f prime of x is 2x plus 4 equals 2x plus 2, and f prime of x equals 0 when x is equal to minus 2. So we check f of minus 3, f of minus 2, and f of 3. F of minus 3 is the left endpoint. F of 2 minus 2 is our critical point. And f of 3 is our other endpoint. So if I plug in minus 3, I get 18 minus 12. I get 6. Plug in minus 2 and it looks like you get 4 minus 8 is minus 4. Plug in 3, I get 18 plus 12 is 30. So I get a local, sorry, not local. I get absolute max of 3 comma 30 and the absolute min of minus 2 comma minus 4. Okay, so that's how that works. B, we have sine of x plus cosine of x. Plus cosine of x. I'm going to call this function g of x, name it something different. So then g prime of x is cosine of x minus sine of x. And I'm going to set that equal to 0 because I'm looking for critical points. Just to note. So looking for critical points, solve this, then we're going to plug in everything. So that happens when cosine x is equal to sine x, or in other words, when tangent of x is equal to 1. So now if you use your unit circle, you see the only place this happens here in our interval is x equals pi over 4. Let me write out the full answer first. So it's going to be pi over 4, and then again at minus, or at 3 pi over 4. 5 pi over 4, sorry. Plus pi k. But how many of those are in our interval? So x equals pi over 4 definitely works. Does anything else work? Well, if I add another pi, then I'm at 5 pi over 4, which is bigger than pi, which is bigger than 2 pi over 3. And if I subtract, I'm smaller than pi over 4. Actually, pi over 4 isn't even in the interval, I just noticed. Okay, so we don't even use that one. So we got critical points, but none of them are in here. So we just plug in the two endpoints. And this is definitely a thing that can happen. Oops, this is G, not F. G of pi over 3 equals G of 2 pi over 3 equals, let's see. So sine of pi over 3 is, let's write these out, pi over 3 plus cosine pi over 3. I get root 3 over 2 plus 1/2 equals root 3 plus 1 over 2. And then for 2 pi over 3, we try the same thing. 2 pi over 3 plus cosine 2 pi over 3 equals root 3 over 2, still positive, but cosine becomes negative, so minus a half equals root 3 minus 1 over 2. So I get values absolute max, pi over 3, comma, root 3 plus 1 over 2, absolute min, 2 pi over 3, comma, root 3 minus 1 over 2. And that's my final answer there. Okay. Finally, part C, I have x squared minus 2x plus 7 over x plus 3, and it's on this interval 0, 2. So let's call this h of x. H prime of x, by the quotient rule, is going to be low times the derivative of the high, which is 2x minus 2, plus high times the derivative of the low, times 1, all divided by x plus 3 squared. Let's solve. So I get, foiling out, 2x squared minus 2x plus 6x minus 6 plus, this should be a minus here, not a plus, by quotient rule. Okay. Minus x squared plus 2x minus 7 over x minus 3 squared plus 3. Now let's combine like terms. 2x squared minus x squared is x squared. Minus 2x plus 6x is 4x. Plus 2x is 6x again. The 2x is basically canceled. And then minus 6 minus 7 gives me minus 13 over x plus 3 squared. So same idea. We're going to go ahead and check for zeros. So either the denominator is equal to 0, in which case x is equal to minus 3. Is that in my interval? It is not. Or x squared plus 6x minus 13 is equal to 0. In which case, again, using quadratic formula, we get x equals minus 6 plus or minus root 36 minus 4 times 1 times 13, otherwise known as plus 52, over 2 equals minus 6 plus or minus the square root of 36 plus 52 is going to be 88 over 2. So now I'm going to use my calculator. The minus 1 is definitely not good because that's not in the interval. But let's check minus 6 plus square root 88. Divide that by 2. I get x equals 1.69, roughly. Again, we threw out one of the solutions because it didn't land in the interval. Okay, so now we just plug in everything. So f of 0, f of 1.69, f of 2, and what do we get? So f of 0 is going to be 7/3. F of 2 is going to be 2 squared minus 2 times 2 plus 7 over 2 plus 3 equals 7 divided by 5. This is 1.4. This is roughly 2.33. And if I plug 1.69 into it here, I just have to use a calculator. 1.69 squared minus 2 times 1.69 plus 7 over x plus 3 is, again, roughly 1 point rounding 30. So what's our max? Absolute max is 0, 2.33. The absolute min is 1.69, 1.30. And that answers that problem.